Okay, so, these are the problems from yesterday. If you didn't do the homework, it will show on your quiz on Friday. The wording is terrible, always, so you need the exposure to it. This is probably the hardest kind, is those that split into 30, 60, 90 triangles. So find the solid, volume of a solid. If it's base, so meaning the shape that it's coming up out of and sitting on, is bounded by the curve. This and the y-axis. Cross sections are perpendicular to the y-axis, so the y slices the x slices which way? Dy. So I need everything as stuff in terms of y, which, okay, we're given. So it's a sideways parabola, and the y-axis, and the shapes that are coming up out of it are 30, 60, 90 triangles with the long leg on the plane. So, should I draw it as a long leg? I'm going to make that shorter. So there's the triangle. So the area of that 30, 60, 90 triangle. What's the length of this line? Okay. And that line, is it just that distance? So this was an exit card from the past, this is someone else's work. But they pulled the triangle out, and drew their little 30, 60, 90 ratio inside, and was like, okay, this side divided by √3 is the height. So it looks gross at first, but area is half base times height, and they're very clearly, okay, the half, the base, the height. They split things up so that they could do the multiply more easily. And we move their 2 over here. Where are they getting that 2 from? It wasn't in the thing a minute ago. Section.
Because they set the bound 0 to 2 instead of -2 to 2, and we know it's symmetrical about the x-axis.
Okay, yeah. So they set the bound 0 to 2 instead of -2 to 2. And that way they can reduce. So they didn't reduce. But showing all of this painful arithmetic. Okay, so I haven't written the quiz yet. My main thing is, can you draw it, can you set it up? I am not so interested in you being able to do a new power rule, so you will probably have to solve some things, but be careful of the wording. I am feeling a lot of set up but do not evaluate, meaning don't waste your time doing the arithmetic, show me you can do the calculus. And if you have it oriented the wrong way, you're kind of screwed. So please read the words, draw the picture. perpendicular to the y-axis, as Cameron said, dy slices. If it's a dy, this is dy, your equation needs to be all stuff with y in it. Like, those are the hints for you. Okay? Today's thing is hopefully easier. So, solids of revolution, when you put a shape on a stick and spin it. Why do we do that? I don't know, a lot of engines have a stick and it spins. So finding the volume of that shape is probably necessary in some things. So, if it's just a straight line, and we spin it, it makes a cylinder, right? So pi r squared is the volume of the cylinder. If I have the shape change heights, it's still just a bunch of cylinders together. So, here's how we're gonna find volume of something spinning. Just pi r squared. Okay, r might be a function in terms of x, but okay. So first thing, draw it. What does, without a calculator, the square root of sine x look like?
Just the positive part of the sine.
Okay, so just the positive part of the sine curve. So sine curve 0 to pi, where does it start up? At 0? What's the highest point? And is the square root gonna still be that same height? So it's still gonna kinda look a lot like a sine curve. Maybe it's a little squattier than that, but, okay. Okay, so let's oh, isn't that cute? So there's this shape, and they're actually splitting it into rectangles. I can make them skinnier so it looks more like a solid. But what we're doing is spinning it and trying to find the volume of basically an egg. Does that make sense? I don't know if the visualizing helps, but so we're going to spin it. So what's any kind of area of just one cylinder? What's the area of the circle that we're going to have to integrate? Next. What is r in this case?
Sine x, vertical sine x.
Okay, ours root sin x, and yesterday, we did a problem where this distance was the diameter. Now, the radius is from the stick that it's spinning around to the curve, so pi r squared, square root of sin x squared is just sin x. Nathaniel, what am I gonna set up to find the volume of the whole A when it's something?
Like the limit,
Yep,
0 to pi.
0 to pi. I'm gonna take this pi out. That's my r squared. So what do you get? Then what's the integral? Whose derivative is positive sign?
Negative
Negative
cosine.
cosine? And the common mistake with these, you forget pi. You write it here and then on the next step you lose it. So it's pi times, negative cosine of pi. Kaya, what is negative cosine of pi?
Negative 1.
It's negative cosine of pi, so it's negative 1.
Oh, yeah.
And then minus cosine of negative cosine of 0. So 2 pi. So the spins are hopefully easier than the Plato problems in this case. 1,000 attempts drawing is an A. Yeah,
Is this the last thing you're gonna have on our quiz on Friday?
potentially. I need to see if washer method is on there too. Yes, this is the last thing. Yeah.
Okay, so yesterday, how is that like different than this? I don't.
Okay, yesterday, these guys are all wrapped because they're spinning. Hang on, let me find. So this time, oh, come on. Wow, very slow to respond. Yeah, my computer's gonna crash. This is a shape spinning, whereas yesterday, the problems that we did were here's a shape, the stuff that's coming up out of this, I'm gonna make them, I don't know, feeling like squares right now. Oh, great, sorry, my great art class is failing me now. But all these squares are popping up, is there anything round about that at all, other than the footprint that it's coming up out of? So that's like the poster on the back wall. There are a bunch of rectangles coming out, and the top part of those rectangles is gonna be the smooth rounded curve, but it's gonna have sharp edges along the top. So that thing back there, is gonna look like that, and very different than a spinning thing. Like if I took, as we just did, that shape and I spin it around this axis, it's gonna look like an A. Or if I do this and spin it, it's gonna look like a funnel or a trumpet or something like that. Okay, draw the picture, yes, Neely.
We always use the area of a circle for the volume.
It'll always be an area of the circle for the spins.
Let's see if I can make the picture work. Do you guys have a picture? Any idea what it looks like? Zach, 2 minus x squared, what is that? Parabola. At x equals 2, at x equals root 2, 0. Amelia?
Oh, so you said
Y-intercept is 2. Okay. Graph. G of x equals 1. George, what does that look like? Horizontal line here. Michael, where are we spinning it around? So we're gonna get this like rugby ball looking egg.
So it looks kind of like this, and spinning it, oops, I'm spinning around the x-axis. Well, that's tomorrow or next week. So never mind, that's supposed to be a solid. All right.
Problem now, my radius is sort of floating. What is that radius? See that? Top minus bottom, yes. So simplifying that, the radius is actually 1 minus x squared. So Sebastian, what's the area formula for one cross section?
For the solute.
For, yeah, this one
That's
circle.
R squared.
Sadie, can we integrate this like the way it's written?
No, I would like distribute the
Okay, perfect. So Alice, what is it when we do the binomial expansion and square this? Adrian, the volume that we're gonna get? What's the setup for the volume of this funky rugby ball egg?
It's 2 pi, and then integral from 0 to 1. The thing we just got.
Wow, Peter is struggling, all kinds of stuff is going on. So, where do you get the 2 from? It's symmetrical, so he's like, I'm gonna just integrate 0 to 1. We didn't actually show that the x value is 1 where it intersects. You guys okay with knowing that you had to figure that out? So he says it's symmetric, I'm gonna go from 0 to 1 rather than negative 1 to 1 and just double this. Okay. Ray, integrating, what do I get?
You get 2 pi times x minus 2x cubed over 3 plus x to the 5th over 5.
Oh. Thank you, Adrian, for making it go to 0, because the second part to plug in is easy. Yeah.
How did you get that the height was like that minus 1?
Well, what Sita said, for the radius of this circle, what is that length? Isn't it the top curve minus the bottom curve? What she said, top curve is 2 minus x squared, minus the bottom, it's not a curve, but a straight line, minus this height of 1. So 1 minus 2/3 plus 1/5. 1/3 plus 1/5. And then times this. Yep. Is okay? Craziness? Okay, all you guys.
Yeah, I have a question. So for this one, I thought it was that you revolved it around like the y-axis instead of the x-axis, like instead of
The question we just did?
the question we just did. So how do you know?
It said revolving around y equals 1.
Oh, it is revolving. So
Let-
that's
let-
the
okay, let me-
axis.
Sorry guys, hold on a second, I need to back up a page. Revolving around y equals 1.
Oh, okay, yeah, yeah. Okay. Thank you.
Where this problem now, what are we spinning around? X equals -1. Ooh, 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 ooh. X equals -1. It's spinning around this way. Uh-oh. What kind of slices are we gonna need? dy. So I need all the equations to have y's in them. Okay, so I drew x equals -1 and y equals 3. I want you guys to do more of the drawing. So, get out the fancy name caller sheets. Where's the front? Here we go. Of course, absent. Kari, can you draw x equals y squared minus 1 on this somehow? Okay.
Should I label like,
If you know the coordinates where they intersect, that'd be great.
would be eight. Wait, what would be the other? I don't know.
It's fine.
And
When x is -1, y is 0. And when x is 2, sorry, when x is 8, y is 3. Do you guys agree with her coordinates? Okay, cool. Adrian, can you color in, like, just hash mark something, the space that we're gonna be spinning? So we need to find the volume of the solid formed by these 3 lines hitting each other. Okay, is that it, or is there more?
I think that's it.
It needs to hit all 3 lines, including that purple line, so yeah, that's it. So he was thinking about coloring stuff in the bottom, but that bottom piece, Ben, do you get it? The bottom piece doesn't touch that front, top pink purplish line. All good? All right. For myself, I like to draw the little arrow to be like, it's spinning here. Someone put up the radius, let's see. Nathaniel. What's our radius?
Should I go up?
Yeah. I don't want to write it. The board's been possessed. I'm going to let it shut down on you guys and blame you. Are we wanting the equation to have all x's in it, or the equation needs to have all y's in it?
All X's. No, all Y's.
All y's, because I have dy slices. So,
Root X.
so I want to, the equation's going to have all y's in it. So do I need x equals function in terms of y, or y equals function in terms of x?
Y equals X.
Other way around. So this equation that Kari drew is x equals y squared minus 1. That's the right side of the curve. So right minus left.
2. With Y squared plus 1, or Y squared minus 1.
Y squared minus 1 is the right, minus the left, which is -1. So write that up there so they can see how it simplifies. So right minus the straight line on the left.
With X.
So the radius is y squared, just y squared? You guys think? Yeah? Okay. So, not here. Sebastian, what's the setup? Come and write the volume for us.
So if you're integrating with respect to y, then you just set the bounds from 0 to 3, and that's the 8.
Okay, come write it.
So
So volume equals, V equals. So is there symmetry to this one? Am I gonna double it? No. Okay. Something wrong, Michael? Okay, so it's a circle, you're just integrating the radius, so I need pi r squared. Okay? Raise the power, divide by the new power, plugging in from 0 to 3. 243 pi over 5. So super requiring visualization. And a number of you have been doing homework without pictures. I don't know how you can do these without pictures. And mine aren't spectacular. But the shape that's gonna come out of this, some like wide, squatty looking funnel. And it's a solid. Okay. Questions? Any questions on yesterday's stuff? Any issues, or do you guys want to start tonight's homework, which I believe is this? Let me check. 392. Bummer. Hold on, it doesn't start there. It starts here. So there's tonight's homework. And someone always asks, yes, number 13 can be solved just doing the volume of a cone. I'd like you to use the calculus to verify that, yeah, I got it, this works. Also, 6th period asked for the delta math from last quarter, the last assignment that was kind of like a practice on a bunch of 7.1 stuff, because that is on the quiz. They asked for that to be brought back. So if you haven't joined the Delta Math class, please do that. And it's optional, but that is brought back and opened again if you wanted to look at questions related to that. I know, Ben, you're going to get right on that. You're going to be like, yeah, it's going to rock my world.